And welcome everybody to an end-to-end demonstration of day zero and beyond with VMware Tanzu Management through vRealize. My name is Matt Bradford. I'm a staff technical marketing architect for VMware, focused on vRealize operations, application, and Kubernetes monitoring. And I'm joined today with Sam McGowan, who's also staff technical marketing architect, focused on vRealize automation. So I'm glad to have you all with us today. So let's just start off with taking a look at, really the capabilities of the vRealize suite. We're going to start with looking at application operations and programmable provisioning. All right, so this is really where our IT consumers, our developers, and app teams can go for, self-service, right, for provisioning those applications and virtual machines and even Tanzu clusters, which is what we're going to get into today. And this allows our service providers, right, our IT infrastructure, our cloud administrators, to be able to ensure that these are provisioned in a consistent manner across clouds, right? Of course, there's a lot of options here between private cloud, VMware cloud, and public cloud. Now, once these services have been provisioned, right, we can start managing them through self-driving operations, right, and looking at things like, are our services being performant, right? Are they secure? Do we have enough capacity for today and tomorrow? Right. So that's really kind of the overall view of what we're doing with the vRealize suite, again, from that day zero provisioning all the way to, the ongoing management of these. Now, of course, for running a software-defined data center, it takes a lot of people, right? It's not a one-person job, and it takes a lot of different roles too. So, of course, we've got things broken out by the consumers of IT resources, so our developers, our site reliability engineers, application teams, right? These are the people that are leveraging that self-service catalog. And then on the other side here, we have our providers of IT resources, right? Of course, our cloud admin, virtual admin, and network admins that are building out that infrastructure, and again, really maintaining it and making sure that it's performant. So if we look at these roles within the vRealize suite, right, of course, we have our application operators, or developers and SREs, right? They're the ones that are consuming these resources through that service catalog. But, in the center here, we have our cloud administrator, and they're responsible for, coming up with those cloud strategies for the business, right? Again, we've got a lot of options, but we're not just going to go deploying workloads willy-nilly, to whatever cloud we feel like, right? That's a good way to get sprawl and get yourself into trouble. So they're the ones that are coming up with the strategies of, okay, how do we decide what gets deployed on private cloud, what gets deployed in the hybrid cloud, and what gets deployed into the public cloud, right? So with that strategy, they're able to also create these services within the service catalog and govern them to make sure that we're only provisioning the workloads we want on the public cloud in the public cloud, right? So, and then on the other side of things, again, our network administrator, right? They're leveraging tools like vRealize Network Insight to make sure that we're secure, right? Make sure that we're not opening ourselves up to any potentially malicious traffic, for example. And then for the VI admin, right? We've got logging analytics for things like troubleshooting and identifying any sort of security risks, and then also the monitoring and management of all of that through vRealize operations. So for today's demonstration, just gonna check the chat really quick here. Okay. So for today's demonstration, we're going to be focusing on a fictitious company called MOAD, right? And MOAD is the Massachusetts Omni Automated Devices. They're a high-end robotics firm focused on industrial applications, right? Shipping, healthcare, manufacturing, as well as agriculture too. So, MOAD's been rather successful since they've been founded. However, back in 2019, they've discovered a whole new market of reaching out directly to their consumers by providing things like electronics kits and robotics kits and other good consumer electronics that are kind of related to that field, right? And so back in 2020, they after this relaunch and the launch of MOAD.io, they bought into VMware VCF, and that worked really well for them. We do have a MOAD demo for that here at VMworld too. So a lot of these demos we're going through the various cloud options. And so, they brought in VMware Cloud Foundation, and that's been working really well. However, with the current times and everything, they've seen just this explosion of demand in their kits, right? Their website's getting hit a lot harder, and they need to start looking at other cloud options. So this is where their cloud admins are looking at a new strategy for deploy anywhere, right? They want to be able to be a lot more agile in being able to move between clouds. So this way they can reevaluate their various cloud providers on a regular basis, and they can move based on cost of these services, or trying to move closer to the end users, right, to provide better service. And so, one of the things that kind of fits this model is Kubernetes. And what this means is that MOAD's developers need to refactor their e-commerce site, right? Their web front end for reaching their consumers. They need to refactor this to be able to run within containers. Okay. And, again, this is going to help them with that portability to be able to move between clouds as they see fit, but also be able to scale out more too, right? When MOAD runs big sales and, just periods of high usage of their, web services, right? They can scale all these out too. So it provides a lot of flexibility, and, looks like a good fit for MOAD, kind of going forward. Now, of course, our developers could just go ahead and, deploy their own services and, develop everything on their own, right, on their laptop, and then move it to services elsewhere. However, again, we've got that cloud strategy, right? And we want to make sure that, again, we're compliant with MOAD's, overall plan here for cloud, right? So in this case, our developers are going to request a Tanzu Kubernetes Grid cluster from their service catalog, right? And, through vRealize automation and CodeStream, we'll deploy that for them on demand, right? Now, one of the big reasons for using CodeStream and vRealize automation over, again, just letting the developers deploy their own cluster is that, like any good cloud citizen, MOAD has a strict requirement for being able to monitor, day two operations. And so that means deploying things like Prometheus and the Telegraph exporter to go and collect metrics from their Kubernetes clusters, right? And then also be able to pipe all of that into vRealize operations. Now, these are things that, the app team or developer, it may be kind of invisible to them and they may not do on their own. So again, this is where automation really kind of steps up and helps MOAD to meet their requirements here. So for this demonstration, we're going to show you how our cloud administrator has, provisioned these Tanzu clusters on top of vSphere, as well as deploying Prometheus, the Telegraph exporter, and piping all of this data into vRealize operations and vRealize log insight without having to do this, manually for each cluster. And so we're going to start off with Sam here, who's going to take us through the beginning processes here.
Okay, thank you, Matt. So I will just start my screen sharing. Hopefully you can now see my service broker screen.
Yes, sir.
Excellent. So we're going to assume the role of that developer coming in to request a new Kubernetes cluster, and we'll imagine it's for a new development branch of a new feature or something like that. And we've got some new stuff we need to test out, so we want a new environment to develop on. And they're presented with their service broker catalog, which gives them a list of catalog items that they're able to access. Now, what we'll do is, because we've got quite a few here, we're just going to stick in the MOAD text, and we'll filter by MOAD, and we've got our new workload pipeline here. So we're going to start a new request, and this is a request that's going to trigger a CodeStream pipeline. But what we've got is a little bit of sort of niceness around the form. We're generating some drop downs in the list. We're doing a little bit of validation as well. and we get a little bit more information as well around those inputs to the form. So the idea is that we can make it as user friendly as your imagination, the system can let you. So first of all, we're going to request it within the context of a project, and this will be our MOAD Kubernetes project. The project gives us a way of delegating resources and who can do what permission sets within the platform. Next up, we're going to create a deployment name. So I'm just going to put dev in there because it's our dev environment. And then we can select the cluster plan. And you can see here that development says it's a single node control plane. Production is a HA control plane. And you'll also notice that this control plane node count also appeared here when we selected production. But we're going to do a development environment, so we don't need that. We'll have a single node for our control plane, and that disappears down here. And so next up is our worker size. So our worker node size at the moment is selected on medium. If we go to extra large, we could have a 4 CPU and 16 gig of RAM t-shirt sizing, but we're going to stick with the medium, 2 CPU and 4 gig of RAM. And then we can also select the same thing for our control plane node size. So we could go for extra large if we're doing a very large production environment, or medium, as in this case, we just want a couple of CPUs. And these reflect the values that are brought out in Tanzu Kubernetes Grid when you're actually doing this using the CLI. We can also select the number of worker nodes we want. In this case, we're going to stick with the 3 default, but we could obviously add as many nodes as were required. And because we're using Tanzu Kubernetes Grid multi-cloud in this environment, this means that we can effectively deploy the same thing to vSphere, to AWS, to Azure, anything that's supported by the TKG multi-cloud CLI. But to do this, we do actually need to supply some IP addresses. So we're going to supply a Kubernetes API IP, and this is the API that we're going to, the IP we're going to access the Kubernetes API, obviously. And we're also going to do a bit of software load balancing. So we're going to use a tool called MetalLB, which is a software load balancer for our services, our load balancer services within the Kubernetes cluster. So we're going to give that a small range of IP addresses that we can then use to create services on. It's worth noting at this point that we can do the same sort of thing with TKG-S, which is Tanzu Kubernetes Grid service on vSphere 7. So we can use the similar sort of process and just integrate with TKG on vSphere 7. Okay, so we'll submit this form, and the developer can basically sit here and monitor the progress of this deployment. They can expand it and have a look at the steps and get some more information. But basically, this is where they will see the response from the pipeline and get the details of their new cluster. So while that's going on, let's switch hats a minute, and we go back in as the cloud management guy, as the cloud admin, and we're going to go into code stream and have a little peek behind the curtain and see what's going on behind this. So as I mentioned before, that service broker form is actually requesting a code stream pipeline. And we have this code stream pipeline up here, the new workload cluster. We can see that we've actually got an execution running here at the moment, the one we've just triggered. And if we click on that execution, we can actually go in and see that there are some steps running, and we're in the deploy TKG cluster step. You can see that there's a little sub pipeline here, and if we wanted, we could jump into the sub pipeline and have a look at the execution of the child pipeline. And then there's 3 tasks that will happen once that's completed. We can also see the inputs to our pipeline here, so we can see the things that have been selected, and also once it's completed, we're able to see the output from that pipeline as well. But while this is running, we're going to jump back into the pipelines and actually explore what's happening in this pipeline, what's going on in the background, and so on. So this pipeline has one stage in it called build. We could have multiple stages and multiple tasks within multiple stages, but our pipeline tasks will execute sequentially along here. Where we've got more than one task in a column, they will execute in parallel. So long as they don't interfere with each other, we can have tasks executing at the same time, whereas we might have a dependency on a previous task that we want to make it sequential. So the first task that we're going to look at is the deploy TKG cluster task. And this is a task type of pipeline. And all this does is provide us a way of linking various different pipelines together. So each of these tasks configured tasks is a pipeline that we're executing, and then we'll return back to this parent pipeline. And you can see here, we've actually got our deploy TKG workload cluster pipeline selected. And we're actually going to be inputting some, we've got inputs for this pipeline, and we're going to take the inputs from the parent pipeline and just feed them straight in to the child pipeline. We're also doing things like appending the execution ID of this pipeline to give it a bit of a unique GUID, so that our deployed cluster has a completely unique name. And we can track all the components that are of that cluster using that ID. So let's jump into this child pipeline, and we can see this one. It's again another quite simple pipeline. We've got 2 CI tasks within the build stage, and these CI tasks will run in the context of the pipeline, and we specify in this workspace tab the context of the pipeline, which will be where we execute and how we execute those CI tasks. So in this case, we are running them on a Docker host in the context of a container that has my TKG tool baked into it. We could also execute in the context of a Kubernetes host, which is a relatively new feature, but it's a great feature for the tool, because it means you don't need to have a standalone Docker host to run your pipelines. So let's select this CI task, and we can see again, it's the type of task is CI, and we've actually got effectively a bash script of steps that we're running to complete this task. So what we're doing is initializing our Tanzu CLI. We're grabbing some configuration information that is encoded as base 64, and it's stored as a variable within the platform. And this variable means that we can ensure that stuff that's secret doesn't get printed out into our pipeline. It also means we can reuse it in various different pipelines and things like that. So I've got my management Tanzu Kubernetes grid config file, which I'm echoing into the standard Tanzu config. And I've also got my Kubernetes config for the management cluster, which I'm echoing into my kube config. And what this does is it means I can use the Tanzu CLI to start deploying a new cluster. Next up, we're creating a YAML file, which is how we're supplying all the information that the Tanzu CLI needs to deploy our new cluster. So you can see here the beginnings of it, that that we got the cluster name and the cluster plan. They're all being fed in from those pipeline variables. We're also going to, at the end of this creation process, we will have a brand new Kubernetes cluster created. But what we want to do is create a new service account, which we're going to use for integration with vRealize automation. So we grab a bunch of information and we export it from this task. So things like the cluster fingerprint, so the SSL fingerprint for the cluster, the address of the cluster, the token that we get from our service account, and also the CA certificate. And these are all things that we're going to need to use to integrate with vRealize operations and also back to Cloud Assembly and CodeStream. So once this stage has completed, we're then going to not freeze up on me. Let's try that again. Okay, so we're going to configure the load balancer, and as I mentioned before, we're using MetalLB as the load balancer to provide effectively a software VIP for our Kubernetes cluster. And to do that, we're just setting up within the context of this container. We're setting up the kubectl command line. We're creating a new context with a server and authentication credentials. And then we're using that to apply a specific manifest from the MetalLB project. We're creating a registry, and then we're dumping into that into a config map the IP address range that we created as an input. So by the time this build has completed, we should have a fully functioning Kubernetes cluster with load balancer available to us. So from there, we'll jump back to the parent CodeStream pipeline, and then we can have a look at the next sort of 3 steps. And it's a similar sort of process. This one's going to configure the monitoring. So we're taking that cluster address, the cluster name, the token, and also the vCenter server that we're talking to, and we're taking them as inputs to this pipeline. And then from this pipeline, we're going to deploy Prometheus. So we're grabbing some configuration YAML files from our repository, and much the same as we were doing before, we're executing them using kubectl. So we're applying those configuration files to our Kubernetes cluster. Once this task is completed, we have a Prometheus deployment on our cluster. We've got a Prometheus container running on each node, collecting stats, and we've got a load balancer available for vRealize operations to access. We also, in this stage, will create a new JSON payload to use in the API later with vRealize Operations Cloud. So I'll come back to that in a minute. Next up, we are deploying FluentD in our cluster, and this is for our log collection, and we are configuring this to integrate and send our logs to vRealize Log Insight Cloud. So this means that we will be able to grab the logs from any pods and containers, from anything that's running within the Kubernetes cluster, and we can use that to analyze things later on. Next up, we are making some API calls to configure a Kubernetes adapter in vRealize Operations Cloud. And this means that we can start pulling in that data from Prometheus and start providing all those good monitoring services that vRealize Operations can show you. So we're posting an API key to grab an authentication token. And then we will grab the endpoint config JSON file that we exported from this deploy Prometheus stage, and we're posting that into the API to create an adapter. And for anyone who's familiar with creating adapters in VROPS, you have to hit a kind of validate button, which will double check the SSL thumbprint for the certificate and make sure that you're connecting to what you want to connect to. And in order to do this via API, we actually have to take the output of that create REST call and post it back as a patch to that API. So I'm doing it 2 different ways here. You can't see it in the REST very well, so I've sort of set it up in the CI stage as well. So once that's done, we've got a fully functioning Kubernetes adapter, and we just need to start the data collection. So we make another REST API call to trigger the data collection and start the process of being able to collect that information from the monitoring. And you can see here that we're taking out the response for the adapter ID, and then we're making an API call to start the monitoring state there. So from there, we'll jump back into this parent pipeline, and we've got 2 further tasks here, which I'm not going to go into because they follow a same sort of pattern. But basically, we're making an API call back to CodeStream and adding our new Kubernetes cluster in as an endpoint. And we're doing the same thing to Cloud Assembly. And we'll see when we come to do the second part of this demo that you need an endpoint to be able to execute Kubernetes tasks natively within CodeStream. So let's have a look and see where we are in the pipeline execution. Okay, so our TKG cluster has been deployed. We can jump into vSphere, and you can see here I've got my TKG folder. I've got my management clusters, in which is the management cluster that I've targeted to make this deployment. And then in the workload clusters, I've got these 4 VMs, and we can't actually see what each of these VMs are here. So let's jump over to the VMs, and we can see the full name. And yes, so we've got dev, which was the name we gave it, the GUID of the execution to give it some uniqueness. And then we've got the control plane node, and then 3 of those worker nodes. So that's exactly what we've asked for from Tanzu Kubernetes Grid. Okay, so our pipelines, now we've executed the code stream and the cloud assembly pipelines to create the endpoints. So a quick look at where the monitoring is. So we've deployed our agents. We've just started making some API calls, and there we go. We've finished making our API calls and started data collection, which is excellent. So where we should be now is that we have our endpoints configured in CodeStream and in Cloud Assembly, and then we should also have collection going on in VROPS and also Log Insight. So we'll very quickly jump down to there's our parent pipeline, and then we'll jump down to the endpoints, and you can see here this dev 02 is our Kubernetes cluster. It's being configured as an endpoint, and we'll just check that works. Yep, so we've validated our endpoint. We can connect safely to that Kubernetes cluster. Similarly, if we jump over to Cloud Assembly, we can go to the infrastructure tab and down to Kubernetes, and we've got a Kubernetes cluster under management here in Cloud Assembly, and we will pull down the kube config file onto our workstation so that we can actually use that kube config later to execute. Our developers can connect via the kubectl command. Okay, and with that, I think I'll hand back over to Matt, and he can take you through the VROPS integration.
Sounds good. Thanks, Sam. Let me share out my screen here. We're going to take a look first at vRealize Log Insight Cloud. Again, now that we've got the cluster deployed here, let's make sure that we are getting the logs in here. And, I've got the content pack for Kubernetes loaded up in here. So, vRealize Log Insight is able to take a look at those logs that are coming in from the Kubernetes cluster. And, it's going to be in a very certain kind of format, right? And so through that content pack, vRealize Log Insight Cloud is able to say, okay, I understand what this log is. This is a Kubernetes log, and I can do field extractions from there. So let me show you what that looks like. So going into the log discovery over here, if I go into my filters, I can filter for obviously various fields. So in this case, I'm going to look for Kubernetes host. Right. So again, as part of that content pack and understanding that these are Kubernetes logs, well, we understand, the structure of that. We understand that, where in that log the host name normally lives, right? So that's how we can extract this. So I can just say, pull out the Kubernetes host where it starts with, and it's going to be dev-02 alpha 8. All right. That's the prefix that we're using for this cluster. So if I go ahead and click on search, here we should see some logs, and sure enough, we do, right? We've been getting quite a few logs here over the last 5 minutes. So that's looking pretty good. Looks like that integration went well. So let's jump over to vRealize Operations Cloud and just take a look at that configuration over there. So, we're going to start off by taking a look at the administration tab here, because this is where, the connections are made for, Kubernetes. So in this case, it's under other accounts. We'll find Kubernetes, and here's our dev cluster that we just barely deployed. So if we go in here, we can take a look at the configuration, and the first thing we have is the URL to be able to talk to the Kube API, right? This is how vRealize Operations goes out and discovers all of the objects within the cluster, right? All of the containers, pods, replica sets, deployments, namespaces, nodes. All of that gets discovered through the Kube API, as well as some properties like resource limits. Going down here real quick, and jump ahead for just a second. And going down here, this is where we can configure the vCenter server, okay? Because we are deploying these Tanzu clusters on top of vSphere, right? We can then tell vRealize Operations where those live. So what that does is it allows vRealize Operations to make those connections between your Kubernetes nodes and the actual virtual machines they live on. And I'll show you this in just a minute. Going into the metrics part here, right, we have the option to either use cAdvisor, which is a developed by Google container advisor, or we can leverage Prometheus to pull in metrics, which is what we're doing here. So going into the credentials, right, this is the bearer token that Sam configured, or that was popped in here when the cluster was deployed, right? And then the Prometheus server, the URL down here. So vRealize operations can go and harvest all that great data from Prometheus. So let's jump into the cluster here. And I'm going to start off, I'm just going to copy the name of this cluster because that is way too long for me to type out. I'm just going to paste it in here and we're going to jump straight to this cluster. And what I'll do is I'll go into the metrics tab here because this is what's going to give me all the relationships, and I can see all of the objects within this cluster. So we're going to start off by expanding out all of the namespaces here. And we've got the monitoring namespace amongst many others, right? But the monitoring namespace, this is where Prometheus has been deployed. So if we go into here and if I expand out the Prometheus deployment, the Prometheus pod, and I can go down to the Prometheus container, right? I can go in and take a look at the metrics here. And again, we've got these node limits, resource limits. These are coming from the Kube API, but we do have this category here called Prometheus. So if I click into here and click on Telegraph Explorer, because this is, again, that sort of shim layer that's sitting out there collecting those metrics from the various objects within Kubernetes. And, Prometheus was scraping them from here. I could take a look at the, say, CPU metrics for Prometheus. And sure enough, we're seeing some CPU activity on here. So I think we can say that this integration is working so far, so good. Now, if we go up here and expand out our Kubernetes nodes, I'm going to take a look at this first node here, and I'm going to go into the details of this. So this happens to be our control plane node. And if I go into the details of this node, of course, we have the node here. We've got all the pods that are living on it. But here we have this connection between the virtual machine and the node, right? So this is, again, why we input that vCenter name into the Kubernetes adapter. And again, that was all done programmatically upon deployment of this cluster. So, from here, I can go from the Kubernetes world, which is over on the right side, into the vSphere world, which is over on the left side, right? Got our virtual machine, we've got our host, and we've got our cluster, right? So I can, take all of this information and these relationships are really important within vRealize operations because then we can start to do correlation, right? If I see something happening out here, well, you can imagine it takes a lot of clicks to go through, look at all the metrics of all these objects down below, right? But vRealize operations can actually, correlate that, that if, metric of interest, or can actually look across all metrics and look for anything of interest, and try to bubble up any sort of potential issues or root causes for issues as quickly as possible. So that's why these relationships are really important within vRealize operations. So that takes us to the next part of our demonstration, which is, we've got the cluster, but now we actually need that application, right? And there are a couple different ways that we can trigger the deployment of this application. And we're going to show you the manual deployment, the manual trigger, not manual deployment. So this would be going into the service catalog and actually requesting our OpenCart application, right? This is our e-commerce site for MOAD. We could also leverage GitHub, right? So when our developer commits code to their Git repository, that can actually trigger a deployment as well. So, a developer commits their code, and moments later they're able to actually run it within this cluster here. They didn't have to do anything in between after the commit; it just sort of happened. Now, MOAD has a requirement still for MySQL to live in a virtual machine. And the reason being, they've got other applications that harvest data from this database, and those don't yet support Kubernetes. So this still has to live outside. Not a big deal. All of our pods, everything can still talk to this virtual machine. And in fact, MOAD's cloud admins are looking to obviously streamline things as much as possible. So they're actually using Tanzu data services to deploy this MySQL virtual machine. And we'll show you what that looks like. There's a cool API for that to trigger the deployment of that virtual machine. And everything just sort of gets hooked up. Speaking of getting hooked up, we're also going to, again, we've got all of that data coming into vRealize Operations Cloud, vRealize Log Insight Cloud. as well as all the traffic flows, network traffic, all that stuff is being observed through vRealize Network Insight. And that's what we're going to show you in this demonstration here. We're going to show you the deployment of the application all the way through to the operations piece here. So Sam, it's back over to you, my friend.
Thank you. Okay, let's fire up my screen share again. And yeah, hopefully you can see everything there. Okay, so we're back in our service broker catalog. And at this point now, we've just committed our latest version of the code to our Git repository, and we want to deploy on our new cluster. So fortunately, we have a pipeline for that. And as Matt mentioned, typically we might use a trigger, Git trigger, and have a pull request, trigger an API call, and start this pipeline. But for now, we're going to manually request this so we can see what's going on. So this is a very simple request. We moed Kubernetes project that we deployed our cluster to earlier, so that we can target that correct dev cluster that we deployed before. We're going to give it a simple deployment name, and then we're going to stick with the open cart password and username. Now, these obviously you wouldn't have in plain text, other than, for example, for a demo environment where you're trying to demo something simply. And Service Broker can help you with that by giving you correct password validation and things like that, and obviously obscuring that. So we're going to hit submit, and similar to our previous request for the dev cluster, you can see that's completed there. We've got an in progress request, and we'll once again jump back over into CodeStream and have a look at what's going on behind the scenes here. So once again, we've got our previous execution here, which we've got a little green tick by. That was our cluster deploying. And then we've got a new execution coming in here. And this is our pipeline, which is going to deploy our SQL server. And then we're going to configure some firewall rules. We're going to tag the VM. And then we're going to also deploy our Kubernetes manifest into our Kubernetes cluster so that we can create our end-to-end application secured with NSX. So at the moment, it's in the deploy MySQL Server stage. So let's head on down a similar sort of process to before. We'll dig into the pipeline while that's deploying, and then we'll come back and have a look at the results of that. So 3 separate stages within here as we looked at the execution. The first one is this pipeline here, which is going to deploy our MySQL Server. So we've got a sub pipeline. We've selected our deploy Tanzu Data Management Services MySQL instance. And then we've got a couple of variables which are going in, database password, user, and also the OpenCart instance. Again, we're tying things together with the execution ID. So let's jump into that child pipeline. And this is the one that's actually doing the legwork with the Tanzu Data Management Services API. So first of all, we will authenticate against the Data Management Services API. So we're posting in credentials and retrieving a token. The next step is this deploy database REST API call. And what we're doing is we're posting a new payload of JSON, which is our template for this database instance, to the provider databases API. Now, it's worth mentioning at this point that Tanzu Data Management Services can also give us, a HA replicating, a highly resilient database. It can also deploy PostgreSQL as well. But in this case, we're doing a dev environment, so we're going to do a very simple single node MySQL instance. And then we're using the poll task within the pipeline, and that's literally the response from our database REST API call is a task ID, and we're going to grab that task ID and poll that task until we see the completed or the failed status. And then once we've done that, we're going to use our good old CI task, and we're going to grab our MySQL script which contains all the image data, all the data for our OpenCart instance. And we're going to use just MySQL commands to connect to the database and just install our content. So once we have that done, we can export the password as well. So here we're using the MySQL command, and we've got our username and the OpenCart password, and we're connecting using the host of the IP address from this get database task. Then we are exporting our base64 encoded password because we need to use that later on to connect to Kubernetes. So when we create a Kubernetes secret, we're using a base64 encoded string. So back to the parent pipeline here. So once this is completed, we've got a MySQL server sitting out there on our vSphere infrastructure. We will next configure some NSX firewall rules. So we're going to go out and just query our NSX manager, and we're looking for a VM with the name OC- and the execution ID. So this will return us an object which contains the virtual machine ID, which we will use in this next task to tag the MySQL VM. And similarly to before, we're making a post with a tag payload that says this machine is a DMS MySQL machine. You're allowed to get port 3306 through from the Kubernetes cluster. So this is giving us the firewall configuration out of the box straight away. And then finally, we're going to use this Kubernetes task to deploy OpenCart. And we are connecting to the Kubernetes cluster that we deployed previously. So that's that dev02 cluster. We are taking an action of applying from source control. We're going to connect to a Git repository, which is my Moad OpenCart demo Git endpoint. And we're going to grab the Kubernetes 00 OpenCart YAML. And if I very quickly switch over to this is the public repository that's got this demo in it. If we go into Kubernetes, we can go into the 00 OpenCart and so on. And we can see the YAML manifest. Now, what you also notice in here is that we have these variables within the manifest. And so when we come down to the bottom of here, we've got some parameter replacement within the file. So we can grab, for example, the execution ID, and we replace the OC instance in the YAML with the execution ID. Similarly, we're configuring things like the database host for the MySQL IP goes in there. The password is going to go in there as well, and it's going to create a secret. So once this task has completed, we just close this one. We should be nearly there. Let's jump into this pipeline. Okay, let's go and see what DMS is doing in the dashboard. So this is the admin dashboard for Tanzu Data Management. And we can go into this dashboard and actually have a look at the databases that are being deployed. So this will give you a list of all the instances and the type of database and the role. So this one's standalone, but it might be a cluster or a replica. And we can see here that we're still in the initializing stage of this database, which means it's deployed the VM, but we're waiting for the configuration of MySQL to complete, which is fine. So it doesn't take that long, a few minutes. So hopefully this pipeline now, we can have a look at the status. Okay, so we've just completed the wait for deployment, which was the polling stage. We've got the database, which is pulling back that connection ID and the information. And then we've deployed our OpenCart database SQL script. And you can see some of the information in this pipeline, but if we select the correct section, we should be able to see the outputs from our task. Freezing up again. Outputs from the task, and we'll note down. Matt, I think you may need to note down this IP address here.
Yeah,
later reference. But we've also got the
44.73. Got it.
we've got the MySQL password encoded as well there. So if we jump back now to the parent pipeline, that's embarrassing. Unfortunately, my open cart deployment has failed. Deployment timed out. Well, Matt, we've just set up all this monitoring and stuff. Is there anything that can help us in this instance?
Actually, Slack, I think, will help us. Hang on, let me share this. This is interesting. So let's go into Slack here. And will you look at this? I just so happen to have an alert from vRealize operations saying that we have a pod that is not available. If I go down here, I can see the pod name is OC699C, blah, blah, blah. I know OC, that's open cart, right? One of our open cart pods that we have deployed. So let's go ahead and jump into this alert here and just take a look, see what's going on. Of course, again, vRealize operations says pod's not available. We recommend you redeploy and fix your stuff here. So what I can do before I jump into, anything beyond here, let's try to scope this out a little bit. And, with vRealize operations, I can actually go ahead and I can jump into this great Kubernetes pod and container availability dashboard. And right off the bat, I can see I've got 3 containers that are having a very bad day. So, the first one here is an open cart container. Second one is an open cart container. Sam, do you see a pattern here?
I think the third one, I would hazard a guess, might be the third. Yeah, open cart container.
Yeah, you should have put money on that one because, yeah, exactly. It's the third open cart. So, okay, all right. Our entire deployment has just gone completely sideways here. So let's jump into our terminal, and we're going to start running some kubectl commands here. So first of all, I need to get my namespaces. I didn't quite memorize this when we deployed. So let me just copy that. We're going to change into that context here of that namespace. So now when I run get all, I'm only getting everything that's in that namespace, right? So all of our 3 pods, which we can see are pending. And then down here, the replica set, right? We've got 3 that we want. We've got 3, but none of them are quite ready yet. So, all right, let's dive into these. Let's take a look at this first pod here. We're just going to describe it and see what's going on. So everything here looks all right, except for down here. Okay, so we have failed scheduling warning. And if I look over here, insufficient CPU. Well, these are brand new nodes. We don't have a whole lot running on them. So let's take a look at that deployment here. I'm just going to edit the deployment. And would you look at that, Sam? We've got a limit of 8 CPUs. That's kind of high. But we're actually requesting 8 CPUs as well. We don't need that for this particular application. We're just testing this out. So I'm going to save this. And now we're going to run kubectl get all. And hey, look at that. We've got 1 pod running. We're making progress here, people. So next we can, I'm just going to go ahead and describe this pod here and just see what's going on. And I've got another warning, unhealthy connection refused. Okay. Not sure what that is. So let's jump into log insight, right? Remember, we're pulling in all of these logs here. So if I go into the log explorer, and I can filter for open cart here. Again, because we're parsing these logs, we have a field that I can leverage. It's called Kubernetes app label, really long name here, but this is, the label that is attached to this application contains open cart. And let's go ahead and fire this off. And would you look at that? First one off the bat here, could not connect to the database. Okay. Good thing we have a tool for that too, right? So I'm going to jump into vRealize Network Insight. And let's take a look at that MySQL VM. Thank goodness I wrote down that IP address, Sam. That was 10.176.144.73. So let's go ahead and we'll click search for that one there. And within vRealize Network Insight, we've got the some basic information with the IP address. We can see some of the flows in here, but I'm interested in the virtual machine because then we can kind of filter things down. There's still a fair amount of information here, right? Like configured firewall rules. But let's jump into the traffic flows. We've got 10 for this virtual machine. And that's 10 is still quite a bit more than I want. So let's go ahead and filter this down. I'm going to filter it for port name is MySQL. Okay, so now we filtered for traffic flows just on port 3306. And if I remember correctly, when we tag that VM, we're supposed to see traffic flowing through here. So, okay, starting to suspect something here. So let's go ahead and expand this out a little bit further. And if I scroll down to the bottom here, we can see the applied firewall rules. And we have this rule called deny MySQL. Well, that is being driven by these tags here. Deny MySQL, deny MySQL. These look kind of suspect. So I'm going to talk to my cloud admin about that. That tagging may not have worked quite the way that he had planned. So let's jump into NSX. Again, I've got that IP address still in my clipboard. So we're going to punch that in here to NSXT, and we can go into the network adapter here, open up that virtual machine, and I can edit it, right? And this is where we can see those security tags and deny MySQL. I can kind of see DMS MySQL, deny MySQL, honest mistake. So let's save that. And I think things should be running from here. So let's go ahead and just pop open our MOAD website, and boom, there it is. It's working. So, I can go in, I can take a look at this cool little lawnmower robot here. But, we can see all the images are loading, all of the text is loading, everything's working as expected here. So I think we sorted out our issues. I just need to go back to Sam and tell him about his potential tagging issue. And yeah, that's the overall demo of the full capabilities of the vRealize suite for Kubernetes here. So really, again, taking you from deployment to troubleshooting and all of that. So hopefully this was useful to you all. And we thank you all for spending your time with us today. Really appreciate it, and hope you have a great day.